Okay, we're going to look at 4 examples today, and the first example is up here. So I'm telling you that cosine theta is 2/5. I'm also telling you that theta is in quadrant 4, and your job is to find the exact value of sine 2 theta. Okay? Now, whenever I see information like this, where it's telling me about an angle in standard position, and it's telling me what quadrant it's in, even if it's not telling me what quadrant it's in, when I have an angle in standard position, I want to draw the diagram. So I want to be in quadrant 4. Here's my angle. Here's the reference angle. Here's the triangle. Okay? So that's my angle theta in quadrant 4. Now, cosine theta is 2/5, and that tells me some information about the sides of the triangle. What does it tell me about the hypotenuse of this triangle? Or in other words, the radius of this circle? What would it be? Colin Olson? 5. So the hypotenuse is 5. Now the 2 is either the x value or the y value. Which one is it? Is it the x value or is it the y value? It is the x value is 2 right there. Okay? Because it's adjacent over hypotenuse, right, for the cosine. Now, I can find the y value by using what? The Pythagorean theorem. So go ahead right now and find what the y value is.
21.
Okay, so it's root 21 because I have 5 squared is 25, take away 2 squared is 4, so 25 take away 4 is 21, so I have root 21. And I need to remember that when I draw it on the diagram, it now becomes negative because it's dropping down and it's a y value in the 4th quadrant. Okay? So that's my diagram, totally labeled with all the sides. Okay? So now let's go back to what we're trying to figure out. We're trying to find out what sine 2 theta is. Now I don't know what theta is, so 2 theta isn't going to be very helpful to me. But I do know that sine 2 theta is the same as 2 sine theta cos theta. And I know what cos theta is because I was told what cos theta is. And I can figure out what sine theta is now because I have a diagram that's going to allow me to figure that out. What is sine theta? What is sine theta? Andring? Negative root 21 over 5. And cos theta, we were told, was 2/5. So when I multiply those all together, I get negative 4 root 21 over 25. Questions for me? All right, next example. Write as a single trig ratio and then evaluate. So we have this 2 tan pi over 6 all over tan squared pi by 6 minus 1. Okay? So when you see something like this, you should be thinking, hey, write as a single trig ratio. Well, that looks kind of familiar to me. Is it one of my identities? Is it one of my identities up here? Is it the same as this one? It's not quite, right? It's close, though. So it's not... But it's close. And in fact, what could I do to this to change it into this? I mean, obviously switch these. But that's not algebraically helpful, right? What could I do algebraically to this to make it look exactly like this? Multiply it by? It's not quite the conjugate. It's actually exactly the opposite of this, right? This is a negative 1. This is a positive 1. This is positive tan squared. This is negative tan squared. So these are the opposite of this, which means that this is the opposite of this. So making this negative, now this is exactly the same. Okay? Which means that this is negative tan 2 pi by 6. Okay, so they're not equal, but they are opposite to one another. So now I have written it as a single trig ratio, but I need to evaluate it. What's 2 times pi by 6, Jamie?
2 pi by 6.
And that reduces to be? Good. And now what is the tan of pi by 3? This is one of your special triangles. Draw it. Remember, figure it out. What is the tan of triangles? Remember your special triangle. It's pi by 6, pi by 3, 90. So it's the same as, or pi by 2. It's the same as your 90, 30, 60 triangle. Label it with the right sides. What is the tan of pi by 3? It's opposite over adjacent. So we have negative root 3. Notice that those are not on your formula sheet. You do need to have your special triangles memorized. Okay? Questions for me about that particular problem? More questions for me about that particular problem? Okay? All right, so the next example, example 3, is a proof. Cotan theta equals cos 2 theta plus 1 all over sine 2 theta. What's the first thing that you would try here with this proof? Nicole, what's the first thing you would try? Yeah, I think I would too. Okay, so we would write cotan as cos theta over sine theta. Now that's as simple as we're getting on the left-hand side. There's nothing else we can do over there to make that look any simpler. However, over here you can see we have some double angles, and we need to get rid of double angles because over here we don't have a double angle. Okay, so we need to have everything in terms of theta. Now the sine 2 theta, there's only one substitution I can make for sine 2 theta. It's 2 sine theta cos theta. But for cos 2 theta, I have 3 possible substitutions that I can make. All of them are equally correct, but one of them is going to get me there faster. Notice that this is cos 2 theta plus 1. So the one that I want to substitute is the one that has the minus 1 in it, because then we're going to get rid of those 1s altogether. So I'm going to write, instead of cos 2 theta, I'm going to write 2 cos squared theta minus 1. So that's cos 2 theta, and then I have the plus 1 there. Okay? So that the minus 1 and the plus 1s are gone. And I have 2 cos squared theta over 2 sine theta cos theta. Now, because this is a single term divided by a single term, I can divide out the 2's. I can divide out one of the cos thetas. And then look at me, I have cos theta over sine theta, and the left side equals the right side. And everyone says yay. Last example I want to look at with you is solving an equation with a double angle identity. We spent a lot of this half of the chapter talking about proofs, but it's important to remember that this chapter is also about trig equations. So solve 1/2 sine 2x minus cos squared x equals 0 in radians over the entire domain. What will we do first here? Any ideas? Since it's in the double angle section of the textbook, then likely you're going to want to get rid of that sine 2x. And you are anyways, okay? You don't want to have double angles and single angles mixed up together. You want them all to be just x, okay? Or all 2x, but you don't want x's and 2x's combined. So we are going to, instead of the sine 2x, we're going to write 2 sine x cos x. And then 1/2 of 2 is just 1. So I have sine x cos x minus cos squared x. Now what will I do? Factor, right. So I have a cos x in both terms. I'm going to factor out the cos x. And now I have two factors that multiply to give me 0. So either cos x equals 0 or sine x equals cos x. Those are the two possibilities. I'm actually going to remove them. Oh, check that out. Never seen that before. Let's try it again. Must have dragged and expanded at the same time. Okay, I'm going to put them down there. Because I want to think about where's cos x equal to 0? So what are the values of x that make cos x equal to 0? Think about the graph of cos x. I'm interested in this point and this point. Where are those occurring on that graph? Henrik?
Pi by 2 and 3 pi by 2.
Okay, good. So that's pi by 2 and that's 3 pi by 2. And again, those ones you have to have memorized. Or at least the picture of the graph in your head so that you can figure that out. Now this is a little different. We've seen this before, but it doesn't come up a lot in solving equations. But where is sine x equal to cos x? Well, if you think about what a sine x graph looks like, let me draw that a little bit better. It's equal to cos x in the first quadrant, where they're both positive, and in the third quadrant, where they're both negative. Where is sine x equal to cos x in the first quadrant? In other words, when is sine and cosine? Which angle has the same value for sine and for cosine? 45 degrees, which is what in radians? Pi by 4. So it's pi by 4 in the first quadrant here. What is it in the third quadrant here? If that's pi by 4 as the reference angle. Matty R, any ideas? So we want all the way here to pi plus another pi by 4. And remember, pi is 4 pi by 4. So plus another pi by 4 is 5 pi by 4. Okay? So those are the 4 solutions in the first period. But I want to have it over the entire domain. So how often are these going to repeat? Every 2 pi they're going to repeat, right? So those two are going to repeat every 2 pi, and those two are going to be repeating every 2 pi. But this is an interesting situation that it doesn't always happen, but it does happen right here. How far apart are those two? Pi. And so the next one is going to be pi, and then pi and pi. So if I keep adding pi's, I'm going to get all of them. So I don't need to put them both. I can just put pi by 2 plus n pi, because that's going to create all of them. And then how far apart are these two? They're also pi. So we would have pi by 4 plus n pi. Now that doesn't always work that way. This is a unique solution where both solutions are pi apart. So if they weren't pi apart, we'd have to list all 4 of them plus 2n pi, where n is an integer. Okay? But in this case, we only have to list 2. It's not wrong to do all 4, you just don't have to, is all. Okay? Questions for me?